Hello students, welcome back to our YouTube channel Geeks for 𝐂𝐬𝐧𝐤𝐬 Computer Science and DA. So in this video we are going to discuss about homogeneous system of linear equation. So till last class we have discussed non-homogeneous system of linear equation and we have discussed that it has three types of solution. Let's just discuss what we have covered till last class. So till last class we have said that AX equals to B. AX is equals to, एक minute. So we have discussed that this AX equals to B system of linear equation, and if B is non-zero, then we have non-homogeneous system, and if B is zero, then we have homogeneous system of linear equation. So let's suppose so we have discussed that AX equals to B has three types of solution: unique, no solution, and infinitely many solution. Now in this video we have to talk about AX is equals to 0, this system of linear equation. That means right side is 0. AX equals to 0, system of linear equation. Now the question arises that would it have all three type of solution, or there should be anything different than non-homogeneous, right? So one thing you can see that AX equals to 0. If you would substitute, if you would take X as your zero vector जो भी रहेगा, then A into X would always be 0. So that means this system AX equals to 0 would always have a solution, AX equals to 0 always has one solution, So that means it would always has one solution. That means there does not exist a case of no solution, right? There would not be any case that it does not have a solution, because every time you would solve, 0 would always be the solution. So that means AX equals to 0 would have two type of solution only: unique solution and infinitely many solution. We'll have only two type of solution: unique solution and infinitely many solution. Now one thing, if you would see that AX equals to 0 has two types of solution: unique solution and infinitely many solution. And before this slide we already have discussed that zero solution would always be the solution. So when I'm talking about unique solution, that means the system has zero solution. So either I can say that it is zero solution, or I can say that it is trivial solution. It has the same meaning: trivial solution. Zero solution or trivial solution. For infinitely many solution, we'll say that it is non-trivial solution. Zero would be the solution. ऐसा नहीं है कि infinitely many के केस में zero would not be there. Zero would be the solution, but there are also non-trivial solution as well. Because the system would always have zero solution. Now the question arises, when this system has zero solution. So system would have zero or trivial solution when rank of A is equals to number of variables. If rank of A is equals to number of variables, then I'll say that number of variables given in the system, then I'll say that it has a unique solution. Rank of A is equals to number of variables. So let's suppose A is of order n cross n. If A is of order n cross n, so can I say that A is of order n cross n? Then can I say that rank of A is n? If rank of A is n, then the system has a unique solution, because how many variables we have? Let's suppose whenever we have a matrix of order, let's say P cross Q, or let's say A has order m cross n. Then what can be the number of variables? How would you decide that what would be the number of variables? Obviously it would given in the question, you would say that. But there are also one more thing, because you want a vector which gets multiplied with this A matrix. So obviously it has order n cross 1. It would have order n cross n1. So number of variables defined by, if you have to find out number of variables, that means number of variables is equals to number of columns in A. Number of columns in A matrix. right? So that's how, like, with only the given matrix A, you can see that in this particular system how many variables can be there. So in this, how many variables can be there is equal n. So it is equals to number of variables. It is equals to number of variable, right? So that means rank of A is n, and A is an n cross n matrix. So that means A inverse or determinant of A is non-zero, because the definition of rank. Or I can say that A inverse exists. A inverse exists, right? This is specifically for n cross n matrix. If I have of order, if A is of square matrix, right? Otherwise I just need to check rank of A is equals to number of variable. Now for infinitely many solution, when rank of A would become less than number of variables, then I'll say that it has infinitely many solution. Rank of variables is less than, rank of A is less than number of variable. And obviously, because when we talk about infinitely many solution, there would be a case of free variable, right? There would be a case of free variable. So what would you do? You would find out free variable, that how many free variables you have. With the help of free variables, I'll be able to generate infinitely many solution, na? Because there should be one variable for which I'll be able to put infinitely many values. Corresponding to that, I'll get infinitely many solution. So what would be free variable? Free variable would be rank of number of variables minus rank of A. That would be your number of free variables. That would be your free variables. Number of free variables. Now another thing is, let's see if I'll talk about a specific case here. If I have infinitely many solution or non-trivial solution, and A is a square matrix of order n cross n. ये मैं specific case I am just solving, right? If A is of order n cross n, A is a square matrix, then rank of A would be less than n, because number of variable is n. If rank of A is less than n, I have determinant of A is 0, and I can say that A is non-invertible matrix, or singular matrix, or anything I can give a name. A is non-invertible. So this is complete chart of homogeneous system of linear equation. If you remember this chart, you would be able to solve the question, right? So let's try one question here. Let's try one question. Let's suppose we have given a matrix 1 2 3 2 1 0 1 1 and 0. This is a matrix. This is a system basically, x y z and 0 0 0. So in this, because their right side is always 0, so there is no need to consider augmented matrix. You can see that in this chart I haven't used anywhere augmented matrix. So what would I do? I'll simply work on matrix A. I do not use matrix B here, right? So what would I do? I'll row reduce this matrix. I'll consider this matrix A. Matrix here is 1 2 3 2 1 0 1 1 0. I'll start solving it. R2 tends to R2 minus 2R1 and R3 tends to R3 minus R1, right? It would help me to get row reduced format. So 1 2 3 0 1 minus 4 minus 3 and 0 minus 9, sorry, minus 6. Right? Now R3 minus R1, 1 minus 1 0, 1 minus 2 minus 1 and 0 minus 3 minus 3. Right? Now I'll reduce it one more step. R3 tends to R3 plus R3 minus R2 by 3. Right? It would give me my row reduced format. 1 2 3 0 minus 3 minus 6. It would become 0. It would become 0 and yeah, minus 6, 3 2s are 6, plus 2, minus 3 plus 2 minus 1. So here rank of this matrix is, now it is in row reduced format. Now rank of this matrix is, rank of A matrix is, let's suppose this system is AX is equals to 0, right? Rank of this A matrix is, rank of the matrix here is, I have 3. and once I got rank of the matrix is 3, so I can say that it has unique solution, and all solution would be 0. Unique solution, 0 solution, कुछ भी बोल सकती हूँ, right? Now one thing you can check that by solving as well. Z is equals to 0, z0, y0, x0. तो इससे भी solve कर सकते हो, otherwise you would get x0, y0, z0 is the only solution. Only solution. So that's how we solve homogeneous system of linear equation. Let's try one more question which help us to understand infinitely many solution. So basically I am just taking a problem here, x plus y plus z is equals to 1, 2x plus 3y plus 5z is equals to 4, and 3x plus 4y plus 6z is equals to 5. I just need to solve this system. अच्छा ये तो सॉरी मुझे तो homogeneous लेना है ना. I just need to take homogeneous system of linear equation, right? So this is my system of linear equation which I need to solve here. Now to solve this, what would I do? I'll first write down in matrix A. So what would be your matrix A? Matrix A would be 1 1 1 2 3 5 3 4 6, right? So I need to find out solutions here. Now one thing, what would I do? I'll start row reducing. So I'll start row reducing. R2 tends to R2 minus 2R1 comma R3 tends to R3 minus 3R1. On row reducing, what would I get? 1 1 1 0, 3 minus 2 1, 3 minus 2 is 1 and 5 minus 2 is 4. ठीक है, 3 minus 3 is 0, 4 minus 3 is 1 and 6 minus 3 I get it as 3. एक मिनट, मैंने ठीक लिया था क्या? अच्छा ये मैंने गलत लिख दिया ना. दिस आई हैव रिटन, ये 3 आएगा, ये भी 3 आएगा. अभी ठीक है, क्योंकि R2 minus 2R1, 5 minus 2 would be 3, right? So this is my matrix. Now what would I do? I'll row reduce it once again. R3 tends to R3 minus R2. I'll get the matrix 1 1 1 0 1 3 and 0 0 0. Now you have to understand that how to write down the solution, right? That is a question. So here rank of this matrix A, rank of A is 2, which is less than 3, which was my number of variables. So it has infinitely many solution. I have here infinitely many solutions. Now one thing you can do here is you have to find out a solution. So that means what you are left with, x plus y plus z, right side would be 0 because there should not be any change, and y plus 2z is 0. Now what is z? Z is your free variable because there is no pivot entry corresponding to z. So z is your free variable. So how do you write down the solution? How would I write down the solution? What would I do? I'll write down here y would be minus 2z and x would be minus y minus z, और minus y क्या था already? 2z minus 2z और 2z into minus 1 2z minus z, तो y is xz आ गया. So now your solution would look like x y z, z minus 2z and z common ले लो, 1 minus 2 1 and this is z, right? So I'll substitute infinitely many values of z, so I'll get correspondingly x y z infinitely many, right? So I have infinitely many solutions. So solution set कैसा है? उसमें 1 minus 2 1 के multiples हैं. I have multiples of 1 minus 2 and 1. But if I'll write down set of independent solution, if I'll write down how many independent solution it has, independent solution is only 1. that is 1 minus 2 1, that is your independent solution. So we get one independent solution here. Solution, all, so if I'll talk about solution set, it has infinitely many solution, but when I talk about independent solution, it has, this is in only independent solution, because any another solution would be the multiple of this one. So that's why it has one independent solution, right? It has one independent solution. So that's how you find out. So in this question, in this formula, you can say that free variables is equals to number of variable minus rank of A. So one thing I can add here, how many, if I need to find out number of independent solution, how many independent solution I'll get. We'll solve one more question, then it would get more clear to you that it would be always equals to number of free variables. So number of free variables are equals to number of independent solution. So I have as many independent solution, that would become my free variables, or corresponding to free variables I am getting independent solution. Z was free variable, the vector which I am getting corresponding to Z, that is my independent solution. Now we'll discuss more questions. एक और question करते हैं. Let's try to solve it. I am writing it x plus y plus z is equals to 1. 2x plus 2y plus 2z is equals to 2. And 3x plus 3y plus 3z is equals to 3. I need to find out solution. अच्छा 1 2 3 भी हटाओ ना. Sorry, you have to take it 0. Right side you have to take it, because we are working on homogeneous system of linear equation. Right? We are working on homogeneous. What would I do? I'll write down the matrix A. Coefficient matrix 1 1 1, 2 2 2 and 3 3 3. The next step would be I'll row reduce. Right? I'll row reduce the matrix. So row reduction gives me R2 tends to R2 minus 2R1 to make this value 0, and the next one is R3 tends to R3 minus 3R1. Right? R3 minus 3R1. So what would I get? I'll get here 1 1 1 0 0 0 and 0 0 0. I get this matrix. Once I get this matrix, you can see here that rank of this matrix A is 1, and which is less than 3, which was my number of variables. And how many free variables I have? Number of free variables, if I need to find out, 3 minus 1, that would be 2. Right? I have 2 free variables here, and I can see that corresponding to this value and corresponding to this value, I do not have any pivot entry. So y and z are my free variables. I can simply say that y and z are my free variables. Y and z are free variables. Now next thing I have to solve is y and z I got as my free variables. I need to find out a solution, right? I need to work for the solution. So x, यहाँ से equation क्या बची मेरे पास? X plus y plus z is equals to 0. And as y and z are free solution, so can I write down it as minus y minus z? X is equals to minus y minus z, and y and z are free variable. I can substitute infinitely many values for y, infinitely many values for z. But how my solution looks like, that is my question. So solution I write down in terms of x, y, z like this. Right? X is what? Minus y minus z, and it is y and it is z. So one thing you would notice here, to write down this solution you need 2 vectors. Y minus 1 1 0, and then you would take z common, minus 1 0 1, and this would be z. So you can see that corresponding to free variable I get a eigenvector. So that means your solution x y z would be a linear combination of the vector minus 1 1 0 and minus 1 0 1. It is a linear combination of 2 vectors, minus 1 1 0 and minus 1 0 1. Again, it has infinitely many solutions. We already get that, and solution would look like this. But the question arises again, if we have to talk about independent solution, what would be independent solution? Free variable is 2, so I'll get 2 independent solution. 2 independent solution would be -1, 1, 0, and another one would be -1, 0, 1. And you can check that these two are independent of on each other, right? You cannot get these two as my non-independent vectors. But the question arises that, ma'am, you have said so many times independent vectors, but we haven't discussed the definition of independence, right? What is independence definition? So let's discuss the definition of independent vectors. So you should remember the definition of independent vectors. ठीक है, एक बार इंडिपेंडेंट वेक्टर्स की डेफिनेशन और डिस्कस कर लेते हैं. सो इंडिपेंडेंट वेक्टर्स, वैसे तो वी नो दैट इंडिपेंडेंट वेक्टर्स, अगर मैं एक वेक्टर को दूसरे वेक्टर का स्केलर मल्टीपल, if I am not able to write down scalar multiple of another two vectors, then these are independent, these two will be independent vectors. But if I have a set of vectors, let's suppose I have this set of vector which consists of v1, v2, vk. I want to know that this set is independent, or this set of vector is independent or not. What would I do? I'll multiply c1 v1 plus c2 v2. I'll solve this, and I'll solve ck vk equals to 0. And if on solving this, what it would give you? It would give you system of linear equation, because c1 into v1 vector, c2 into v2 vector, c3 into v3 vector. So you would get system of linear equation. On solving this, if you would get, if I'll get, if all ci's are 0, then S is, or you can say that S has linearly independent vectors. If at least one ci is not 0, अगर कम से कम एक ci मिल जाए that is not 0, then you would say that then S has linearly dependent vectors. Right, so that is a definition of linearly independence and dependence. Let's take one example. If I'll take this set of vector, let's suppose I am taking S as 1, 2, 3, 2, 1, 4 and 0, 1, 0. This is my set. I want to check that this set S is linearly independent or not. I want to know that this set S is linearly independent or not. What would I do? I'll write down C1 into this vector 1, 2, 3 plus C2 into this vector 2, 1, 4 and plus C3 into this vector 0, 1, 0. Right? What you would get? You would get 0, 0, 0. Right? This 0 does not mean you would get single 0, right? Like you would work with the matrix. If I'm writing A, matrix A is equals to 0, that means right side is a 0 matrix. And if I'm taking it as a vector, so right side is a 0 vector. Now, let's see this. So what would I get? C1 plus, you know that how to add vectors, right? C1 plus 2C2 plus 0C3. ठीक है, उसको लिखने की जरूरत नहीं है. Right, next term would be 2C1 plus C2 plus C3, and the last term would be 3C1 4 plus 4C2 is equals to 0, 0, 0. Now if I'll see this, what would I get? I get this C1 plus 2C2 0, 2C1 plus C2 plus C3 is equals to 0 and 3C1 plus 4C2 is equals to 0. I want to know that this system has a 0 solution or non-zero solution. I know already I have solved homogeneous system of linear equation. So I know that this, how to check this system has a 0 solution or non-zero solution. So let's check. So the system I got here is C1 plus 2C2. I am writing it here. C1 plus 2C2 0. And another one is 2C1 plus C2 plus C3. I want to check that they are linearly independent or not. 3C1 plus 4C2. C2 is equals to 0, right? So what would I do? I'll find out rank of A, right? So what is A matrix here? A matrix would become 1 2 0 2 1 1 3 4 0, right? So what would I do? I'll row reduced it. R2 tends to R2 minus 2 R1, comma R3 tends to R3 minus 3 R1. What would I get? Let's reduce it. 1 2 0 0, 2 2s are 4, minus 3, and it would be 1. 3 minus 3 0, 3 2s are 6, R3 minus 3 R1 है ना 6, so minus 2, and it would be 0 as it is. Right, now I have to row reduced it further. What would I do? I'll just make this value 0. So R3 tends to R3 minus 2 by 3 R2. What would I get? 1 2 0 0 minus 3 1 and 0 0 minus 2 by 3. Now rank of this matrix A is 3. So that means it has unique solution, or you would say that 0 solution. 0 solution. So that means all C1 0, C2 0 and C3 0. Right, all three vectors, three values are 0. So you can say that this set S is linearly independent. So I can say that S is linearly independent because there does not exist any C1, C2, C3 such that linear combination of all the vectors would be 0. Right, but one thing you can notice here is that I have taken 1 2 3 2 1 4 0 1 0. मैंने क्या किया? I have multiplied it with C1, C2, C3, solved system of linear equation, and then system of linear equation से I got this matrix A. But one thing you can check here. First vector is 1 2 3. First column is 1 2 3. Second vector is 2 1 4. Second column is 2 1 4. Third vector is 0 1 0. Third column is 0 1 0. So directly, so the point here is that directly you can form the matrix A instead of converting it into system of linear equation and just like taking constant and all those things. You just need to check rank of A. So I can just get the, I got here this result. Can I say that? Let's suppose S is a vector. S has vector v1, v2, vn. Let's suppose S has n vectors. Right, S has n vectors. Yeah, I'm writing result. So what would I do? I'll make a matrix A in which I'll write down v1 vector. Right, यहाँ पे v1 vector आएगा पूरा, v2 vector, और इस तरीके से I get vn vector. What would I do? I'll find out rank of this matrix A. But I'll solve for rank of A. If I'll get rank of A is equals to number of variables, number of vectors I have taken. Number of vectors in S, number of vectors in S, then rank of A is equals to number of vectors in S. So that means it has a unique solution. It would have a unique solution, or I'll say that S has linearly independent vectors. Because what does it mean? It means that you would get rank of the matrix A is equals to 3. Right, same thing. S has linearly independent vectors. If rank of A is less than number of vectors in S, S has linearly dependent vectors. S has linearly dependent vectors, right? So that is a whole point. Now my question with you is, you guys would let me know in chat section later on after this video, after watching this video. This is your question. You just have to let me know, can rank of A is greater than number of vectors? Would it be possible? And if it is possible, why? And if it is not possible, why? So let me know later in comment section, right? So can rank of A is greater than number of vectors? You have to check that, right? So that is what we have for homogeneous system of linear equation, right? That is the whole concept of your homogeneous system of linear equation, and that is like we got independent solution here. We have infinitely many solutions, but part of it also tells us that you have number of independent solution, which are number of free variables, right? So till we are going to cover more questions on homogeneous system of linear equation in next video. Till then, you just go through all the concepts of this and try to solve these questions by yourself. So that's all for this video. Let's continue in the next one. Thank you.